Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us move to the next module, and still under module 5, which is about bridge engineering. Module 5 is about engineering plan. What are the engineering plan requirements for bridge? So let us proceed. So we have the engineering plan set. So a set of plans, how they are organized, and what are the content. Okay. So we have the following. So first and foremost, we have plan and elevation. General plan and elevation. As you can see, this is in the standard in the United States. Okay. So we have a different standard in our country, and we have the format for our what? For our engineering plan, wherein there is a what? Approval column here on the side, and the title box here below. So, and then the contents inside. So, elevation and plan. Okay. So, plan view and elevation view. That is what we mean by this. Okay. So, if we say plan view, we have actually the top view. We have plan view. So elevation view, we have actually the side view. That is what we mean by elevation view. That is side view. That will involve what? You can show the foundation, the footings actually. Showing the footings, right? So it shows the footings. Okay. So we'll just familiarize ourselves. We will not, we don't need to understand each and every word here, but what? Low chord. Okay, that is a truss component on the lower portion of the superstructure, low chord. Okay. So section along column 1, so cross section. So we have here what? Riprap. So the end. Riprap is the end of the what? Of the bridge. Okay. So this is a plan view. Files not shown for clarity. So they omitted the files. We know there are files here. And there are files. Okay. On the what? The this is the what? Bottom of footings. Okay. So spread footings and there are files. Okay. Typical section. So we need cross-section view. Must be drawn in engineering plan. So just like what we had on our previous modules, we have the same familiar what? Parapet. Then what? Is now the pavement with what? You can show the layers. You can actually show the layers of the pavement, but there's none, only the whole pavement with what? The showing the reinforcement bars. Okay, it shows the reinforcement bar. So this part is shown in detail A. So this is detail A. So that part is this one. So this is the part. Okay, so built up part from that section. Okay, so these are the what? Cross frames. Okay, these are the cross frame. So we have typical design of single bay, another bay, another bay. Bay meaning one regular section of one repeated section of the what? Of the bridge. That is a bay. Okay. So grade point. So meaning that is the what else can you see? End bend. So what do you mean by end bend? Okay. Diaphragm and bent diaphragm. So bent is where the end of the bridge starts and where the highway ends. That is bend. Okay, end bend. What is another word for that? So already, okay. Typical section, blow up view. So this part, if you can see on blow up view of the typical section. So beam booster here, in between the reinforcement. So this black dots are reinforcement. Okay. So this is steel bars going there, going letter U, steel bars, letter U, steel bars. Then there is what? Provision for connecting one steel bar to another. Okay, so splicing, that is what we call splicing of steel bars. Okay, so top of the slab, this is the top of the slab, one. Okay. Okay. So this is the what? This is the high beam booster. So high beam booster. We have high beam booster here. Okay. Interior girders. Okay. So interior girders. This one. This is a girder. The interior of the girder here. Okay. So it is a girder. This one is a girder. So two cross frame and girder. So girder to girder distance, that is what we call bay. Okay. So then on top of the girders, we have what? Deck and slab. Framing plan, we need that. So section plan, elevation, plan view, and framing plan. So we have this framing plan. Okay. So that is the framing plan for unit 1. So there are several notes. Okay. So take note of the importance of notes. Okay. For example, all structural steel shall be AASTO M2TO grade 50M and painted in accordance with System 4 of Article 442-P of the standard specification unless otherwise noted in the plans. Okay. All dimension shown are horizontal or vertical unless otherwise noted. So those are the type of notes or specification, okay, indicated here. No, so this is what superstructure, structural steel framing plan. So superstructure framing plan. That's how. Okay. So frames. So you can see all the frames here. Span A, B, and C. Okay. So bend 2. Okay. Bend 1, control line and bearing. Okay. Control line and bearing. Bend. Okay. So intermediate diaphragm. This one. So this is the intermediate diaphragm. Okay. So we already shown you what is the picture of the diaphragm. So that is the diaphragm. Okay. So another intermediate step required per girder. So stiffener, so bracing. That is what I shown also. Okay. So what else? Bearing. So including the bearing. So they are showing the bearing in the spring plan. So from the bearing to the upper part, the superstructure components. Okay. So framing plan. So blow up view of the framing plan. Okay. So fill paste and bend. Okay. So fill splice. So that is the splicing part. Okay. So there are again intermediate diagram, bearing, center of bearing, meaning the location of the bearing. So number 5, girder elevation drawing. So girder elevation drawing looks like this. Elevation meaning side view. Okay. So side view of the girder. Okay. elevation, plan of bottom plans. Okay. Okay. Plan meaning top view or bottom view. Either top view or bottom view. Okay. So plan of bottom plans. Okay. Bottom plans. This is the bottom plans. But this is the top view of the bottom plans. Okay. To show the connection. To show the connection. So that's why we have plans. So what do you mean by plans? We already know what is plans. We already know what is web. Okay. So connect all the learning so that we can understand the drawing. So stud, spacing, dimension. The studs are the support. Okay. Stud is the horizontal and vertical support. Okay. Sometimes we have V nuts test. Okay. So Sharpie V nuts test is for what? Surface toughness test. Okay. Girder dimension. So also placed here. So different tables included in the plan. Okay. Tabulated. So because there are what? Several sizes, several shapes. Okay. That's why we have those. So this one is an important one. That's why they are given the symbol cloud. The cloud symbol. Okay. Cloud symbol. Important portion. So those connections are what? Connector plate, bearing stiffener. So those are what? Fill paste and end bend to existing. Okay. Place all intermediate web stiffener on the inside face of the web on interior girders. So there is an instruction how to do it. So this plan is for constructing the girder itself. Okay. So blow up view of the girder. Okay. So important parts there. This one. Plates connecting butt connection. This is a butt joint. Butt joint. Okay. So butt joint. So we already know what is butt joint. I already have an example of butt joint in the problem solving in one of our courses. So that is the butt joint. So we can notice here butt joint. Okay. So stiffener plate, condition, field splice type, and so on. Okay. So cross frame details. Even the cross frame, we have the details. These are the construction detail, how to connect this element to the other. So gusset plate. We are using gusset plate here. Gusset plate. Okay. So again, important here. So again, cloud. Whenever cloud, those are important information because it is with the cloud symbol. Actually, they are what modification, what amendment. They are updates. They are updated size or shape or specification. That's why it is written in cloud. Okay, symbol. Okay. Note, stiffener. So where are the gusset plates? So this is one gusset plate connecting this part. This again a gusset plate. So this is what we call gusset plate detail. This is gusset plate connection detail. So this one. Okay. So this gusset plate is what? Welded. This is the symbol for weld. This is the symbol for weld. Okay. These are the symbol for bolt connection. Okay. So we will familiarize ourselves. So this is the what? Bearing stiffener here. So we have we already know the types of bearing. We already see familiar this type of what component. Okay, so intermediate stiffener. So side view. Okay, so let us look at the bearing details. So included the bearing details. So details here. So we have what? Piston. We have what? Brass sealing ring. So it has more details. Okay. So what we learned from previous modules are general information, terminologies, nomenclature, description, explanation, and there is no details. So these are the details included in the plan. Okay, so included in the engineering plan. So this one is what type? Path bearing. So this one is a path type bearing. So cutaway view, cutaway plan, plan view, and elevation view. This is the showing the dimension in top view and side view. Okay. So because there is no what? There is no 3D view. That's why we need top and side view. Okay. So we have the bolts. Okay, fixing the plate. Okay. So this is M3. 10 of this required. M1, 5 of this required. M2, another 5 of this required. So a total of 10 required. Okay. For the plan. Okay. So elevation view, plan view, elevation view, plan view. Okay. Table for loads and movements of these different bearings. Table for plate setting data. Okay. So sliding surfaces. So we have here, no? So masonry bearing plate type. So the masonry bearing plate type of connecting the bearing to the pier cap or pier column. Okay. So these are the important things. So the contractor may, for example, substitute this bearing for the path bearing. So there are provisions for that in the design. Okay. So table for loads and movements. For example, we have now bend 1, 2, 3, 4, 2, 4, and 5. So we have dead load, live load. So remember that. Next, we will talk about dead load and live load. So recall, we have dead load, live load. Okay. And you already know dead load and live load from what? From the theory structure. Okay. Factored load, lateral. Okay. So what do you mean by factored load? I don't know. I think you already learned factored load in theory structure. Okay. What is the factor for dead load if you are using LRFD? Okay. So I will look after those review. I will ask you each and every one of you. Okay. So we have bearing details and so on. Again, this is the end of the video. This is Dr. EYPEI, Preaching Engineering for Nation Building.